better to share full screen. Okay. The board is visible?
Yes, sir.
Everything? Okay.
Yes.
So I can't read any message or SMS. Okay, so since I am using full screen, if you want to say something, you have to unmute yourself and you have to inform me. Okay, if you are not, if it is not visible or audible or anything. One more point. Okay, don't send any mail to my gsmahapatra@gmail.com. You have to send all this correspondence. You now I am using that one, trgsmphd@gmail.com. Okay, in that one, this one only. And my WhatsApp number 97598111189. Clear? So these two information, don't send any mail. Okay, it will be not recorded if you send in that my email gsmahapatra@gmail.com. Don't send only this one. Okay. So now properties of Laplace transform. Okay. So what is the properties? What are the properties of Laplace transform? We will study one by one. Okay. So and with applications, so with example. Okay. So what is Laplace transform of f of t? F of t. What is the formula? Somebody can prompt. I will write then.
Integral 0 to infinity e power minus st into f of t.
Minus st into f of t. Very good. dt. So now, is it correct? Okay. So now I will ask you some questions before writing any properties. Okay. So L. Okay. C is a constant, complex constant, say, or real constant. What will be the answer? C into f of t. F of t is a function. So simply multiply
C
by
into Laplace of f of t.
Correct. Good. Your answer is very actually compact answer. Okay. I have written down. So this one. Or else you can write C into integration of that one. So if this one holds, okay, if this one holds, what will be the first Laplace transform, properties of the Laplace transform. So okay, what you have to write? If f of t and g of t, okay, f of t and g of t are function having Laplace transform. Both are actually, it is already defined that both are having Laplace transform. Okay. So if and we are functions, function FUNC. Okay, are functions having Laplace transform, say that is f of s and g of s respectively. Okay, na? Respectively. Okay. Then this is first property. Then what will be the Laplace transform of sum of that two? Okay, sum of that two. Anything you can write C. Okay, sorry. F of t plus g of t, if you want to take Laplace transform of these two, what will be the answer? So the answer is, it is actually f of s plus, okay,
S.
g of s, yeah, fs plus gs. So what is the name of this transformation, this type of properties? The name is linearity properties, Li, linearity, okay, linearity property. So that is, okay, it is called linearity property. So linearity property. So now this is the linearity property. I can add something, say here a and b. Can I add? Since just earlier discussion we have already discussed a into f of t plus b into g of t, correct or not? So what will be the answer then? It is a and b are any constant, then it is a and b, correct? So I have written only plus a into f of t plus b into g of t. Is it true for if it is minus?
Yes, sir. It will hold.
It will
Hold. It will hold.
It will hold. Okay, correct. So your answer may be, if b equals to say minus b1, then it is like that only, a f of t minus b1 g of t, correct?
Yes, sir.
You are correct only, but just for simple concept, since we have written a and b are any arbitrary constant, okay, constant, then it is. So I am not writing the number, only linearity property, okay, of Laplace transformation. So now you already know, in the last class we have already evaluated the Laplace transform of t, correct?
Yes, sir.
What is the answer?
C by S, something.
T by, hey, don't say C by S. Only T I told. What is the answer?
1 by s square, sir.
Correct.
No, 1 by S square, yes, sir.
For all of you, okay, you should have one notebook for mathematics class, okay, na? Like you are attending class, offline classes like that, okay. So it will be easy for you also during examination time or in future reference, okay. And what is the Laplace transform of C? That one also we have discussed, correct or not?
Yes, sir, we discussed.
What is that one? So now example, you don't have a notebook, I know, that's the problem, okay. So now if I ask, find the Laplace transform of f of t equals to c plus t, what will be the answer? Since you know the Laplace transform of c and Laplace transforms of t also, in the last class we have already discussed. So no,
We'll add the both answers.
yeah, correct. So the Laplace transform of now f of t is not like that. It is actually now f1t plus f2t. In that sense, you can consider. Okay. So since I have considered very simple example, c and t. Now itself I can find the Laplace transform of. Okay, find the Laplace transform of any such particular, say 3t plus, okay, 2 to the power 3t. Then two function. Now it is not so easy. Okay, now two function. Okay, so we have to find. So this one is f of t, say, and this one is g of t. Now, correct. But why I have considered very simple one? You should have the concept only. No need to do the calculation unnecessary. Okay, now. So what will be the answer? Now Laplace transform of C plus Laplace transform of t. That will be the answer. So what is the Laplace transform of C? Somebody actually already C, correct?
C by S.
C by S, okay, plus 1 by
S.
1 by s square.
so that one.
S square.
So this is the applications of Laplace properties. What is that property? Linearity properties. Okay, I will not consider any problem right now. Okay, so next property is Okay, so now C into function or any two add or subtraction of two functions, you now understood that it is a linearity condition. So you can consider the Laplace transform of two functions and more. So now, sorry, previous one. So this is only two. Can we find what will be the process if we find? You have to find T square. Can we do that one? Correct. Only linearity property. So f plus g plus h and so on. F, g, h are the function of t. It is applicable for such type of sum of all the functions. Correct. So Laplace transform of f plus g plus h and so on. What is f, g, h? Function of t. Okay, I have not written. You understood that one. That's why I have not written. So Laplace transform of f of t plus Laplace transform of g of t plus Laplace transform of h of t, and so on. Then add. This is the concept. Okay, next property is called the first shifting property. Okay, I will write. Okay, so since it is first shift, then there should be another one. Okay, second shifting property. Okay, now that one also will. Okay, second shift property, or sometimes it is called second shifting property or first shifting properties. Okay, now what is that one? What is first shifting property? Very important one. Okay, sometimes you have to state, or sometimes you have to prove this one also. I'm telling regarding the exam. Okay, now. So what is that statement? Okay, if f of t is a function, okay, having Laplace transform f of s, capital F of s. So okay, f of s, where of course you know that r real part of s is greater than 0. Okay, or some other. Okay, or this is maybe some particular value. Okay, now then the function e to the power. Okay, so now e to the power at into f of t. Okay, what is the Laplace? Then the function, okay, of this one, okay, also, okay, has a Laplace transform. Okay, so what is the Laplace transform? That means you have to find Laplace transform of e to the power at f of t. Okay, so let us consider f of t equals to t square. Okay, or f of t equals to t. Just few minutes back you have already means you told that f of t, Laplace transform of f of t means equals to t means 1 by square. You have already told that one. Okay, so now t into e to the power at, what will be the Laplace transform? Okay, so that one. Now what will be this one? I will write before that. Okay, I will write first. Then what will be the answer? Now f of s minus a. Okay, so what is that one? F of s minus a, and I will just tell you some little bit this one. Say f of s equals to s square, say, or 1 by square. Okay, 1 by square. Then what will be the f of s minus a? It is 1 by s minus a whole square. So that is the case. So that means no need to, if you know the Laplace transform of this one, okay, Laplace transform of this one, no need to find again the, if it is f of t well-known function, correct? And you know that one, clear? So in that case, you no need to find again the integration. Only what you have to do now, the function should be replaced, f of s should be replaced by f of s minus a. So clear? Anybody having any doubt? So what? Just 1 minute. I want to remove this one from here. Okay. It is not moving. Okay, let it be there. Okay. So now I will consider some example. Before that, okay, what is the short form of this one? You can note like that only. It will be easy for you. Okay, okay. You can easily memorize this one. Okay, Laplace transform of, okay, e to the power at f of t. Correct. This one. What will be the answer? Now, f of s. You know the Laplace transform. Okay. This one you just replace. You just replace this one s replaced by s minus a. If somebody is writing anything, actually I can't able to see that one. I have already told you. Okay, it is with full screen. I am doing this job, so you can't. I can't see any SNS or anything. Okay, so s changes to s minus a. Where? What is that one? Provided that the Laplace transform of f of t is capital F of s. This one is given. This one is given, or you know, this one is all known function. Then that one. So now what I have written here, this one for this case, this particular case is nothing. F of t we have considered t. Then what is the Laplace transform? Just see. If you want to find the limit integration, it will be very tough. T into e to the power at. What is the Laplace transform? So what is the answer? Now f of s. Okay, and that one s replaced by s minus a. What is that one? Now 1 by s square. Correct. So s replaced by s minus a. So that is 1 by s square. Sorry, s minus a whole square. So this is for your one example. Say okay, little bit. If it is okay, you have to find. Now you should have pen and paper. Okay, now applications of first shifting properties. Correct. So now for odd roll number. Okay, odd roll number. Okay, e to the Laplace transform of t e to the power minus twice t. What will be the answer? And for even roll number. Okay, even roll number. Laplace transform of, already you have studied, that's why I'm telling. Okay, e to the power minus 3t. Okay, sine twice t. What is the answer? So this two we have to find. So what we have to do? Don't find the integration. Integration 0 to infinity t e to the power minus 2t into e to the power minus s t and dt. Don't do that one. Okay, that full class will go. Okay, 50 minutes we will take. So not now 15 that's 20 minutes left. Okay, so better not to do this one. So what you have to apply? Properties of fast shifting property you have to apply, FSP. Okay.
Sir,
Yeah, tell me.
even roll number we did cos, sir. Sin is the same thing, or it becomes s square minus a square at the denominator.
Okay.
We did cos, sir.
We did?
Cos, sir. Even
Oh.
roll number.
Oh, no. Acha, cos. Okay, level. Okay, fine.
Okay, thank you.
Now fine. Okay. So now what you should not write directly all the steps you should write. Okay, now. So for example, okay, now. For example, okay. So we know that. Okay. We know that, or if you have already evaluated, then it's okay. A Laplace transform of t equals to 1 by s square. Correct. Okay. Now this one. Now applying. What is applying? We are applying Laplace. Fast shifting properties of Laplace transform. We get. Okay. Next page. We get. Okay. L of Laplace transform of e to the power. Okay, at into e to the power, what we have considered? At f of t, okay, equals to, that is first shifting property only I am writing. Okay, now f of s. That implies Laplace transform of t e to the power minus 3t equals to f of s. Okay, we know the answer. Okay, tell me what I should write. S replaced by what roll numbers? No one is there.
S plus 3.
S plus 3.
So 1 by s square, correct? So replace s replaced by s plus 3, not s minus 3. Okay, formula is s minus 3. So this is the answer. Okay, now for even roll number, what is the answer?
Sir, s plus 3 divided by s plus 3 the whole square plus 4.
S plus 3 divided by,
S plus 3 the whole square plus 4.
oh, this one is the answer. Okay, good. So for simplification, you can write s plus 3, okay, s square plus 3 into 2, 6s plus 9 plus 4, 13. Am I correct? So this form. This is the answer. I don't know this one is correct or not. Okay, if anyone having some different answer, you can tell me now. Okay, or you can tell your friend what is this answer is not correct or correct only. Yeah. Okay. So just for odd roll number, I have not written provided that one. Can you give any input from this one? What will be that? What will be the real part of S? Real part of S, what will be the answer? No one is
Greater than 0.
greater than. Are you sure? Greater than 0, if it's then it's okay. Okay, greater than 0 is always correct. But even if it is s not equals to minus 3, that means greater than minus 3, then it's also defined. Correct or not? S equals to minus 3 only, it is not defined. Okay, so you can write f of s greater than 0. If you find that one, okay, you can see that RE of s greater than minus 3 also you can write. Greater than minus 3, not equals to. Okay, that one also you can write. So greater than minus 2. I repeat, okay, that your answer is correct, but that is for 0 minus 3. The answer is 0 minus 3. So real part, you have to see that this is defined or not. So real part of, okay, real part of this one is greater than 0 minus 3, that means minus 3. Is there any such condition for the even roll number? Just think and tell me.
No, sir.
Unfortunately. Yeah?
I don't think so.
You don't think so? If okay, s equals to minus 3, what is the then this
So
one?
that
Laplace
actually 1 by s will come, sir, when we
1 by s, for 1 by s, the real part of s is greater than 0, correct?
yeah.
But
So
now I
yeah.
am asking for this even your even roll number, your answer is this one. Is it defined for this function, right hand side function, that is algebraic function? Okay, s is complex of course, but it should be a algebra. Okay, only. So what is algebraic equation only? So what is the value of s? For what for that value the function is not defined. There will be no s, but you have taken Laplace transform. If there is no s, then meaningless, na? Correct, na? F of a Laplace transform of t, if there is no s, 1 by 3, that means that is wrong only. Correct, na? Or t into e to the power minus 3t, if there is no s, only 1 by 0 plus 3 whole square, that means 1 by 3 whole square means 1 by 9. That is not possible. So what is that case? You can easily answer it from this form itself, not this form. this form itself can from here itself you can answer what is the value of s. That means real part of s. So there will be no s. So actually the case is real part of s. You remember such that of any function product or multiplicity of anything, then real part of s should be greater than -3 here also. Why? Unfortunately, it is actually just 1 minute. I have written wrong. This is -2, correct? So this is wrong actually. This is -2. Sorry, 2. So this is 2. So this is 2. 0 minus 2. This is 2. Okay. Okay. Now for this case it is 3. So s plus 3 by s plus 3 whole square plus 4. Correct. Okay. So such case, can you tell me the answer, the previous answer? What is the Laplace transform of cos of t?
S by 1
by s square plus s.
S square plus
1.
1.
Oh yeah, oh cos t, 1 by.
But then why it is 4 by? Is it wrong or correct? Sorry, it is
Sir,
correct or
here
wrong?
cos 2t.
It's
Cos
sir.
2t, sir.
Cos 2t,
Okay.
sir. So a is
Okay.
equal to 2.
Very good, very good, very good. Okay. So now that means first initially we should write 2 square. Okay. Then you only one is expanding, one is remaining same. It's not good. So now in that case, cos of t, what is the provided condition? That means s by s plus a square plus s s square plus s square. What is the provided condition? The real part
the real
of
part
s
of s is greater than
should be greater than 0. Okay, correct. So
0%.
now you from there you just say real part of s. So that is a real part of s is greater than 0. Correct. So there is no 3 that time. Correct now. So now you tell me from there how can you define this one? What that real part of this one? What will be the answer? You are not responding now. Real part
So
of
real
s.
part of
Real part of s when you are writing s by s square plus s square. Correct. What is that one? Laplace transform. I will go to the new part. Okay now. So your Laplace transform is okay. Laplace transform is s plus 3 divided by s plus 3 whole square. Am I correct?
yes, sir.
Okay. And this one you have actually derived from what? Laplace transform of cos
Cos
of
2t.
2t. Okay, cos 2t. That answer is s by cos t say initially. Okay now, or cos 2t also no problem. Correct. So s by s square plus. Am I correct?
Square.
This one correct. So in
Yes,
that
sir.
case, you have written real part of s. What is the answer?
Greater
Greater
than
than
0.
0.
How it is actually? Correct. So that's why you have written s part is greater than 0. Understood this one? So if it
Yes,
s
sir.
part real part is not 0, so then it will be 0 only. Okay. So nothing is there. Why I have written? You can write s 0 plus or 0 minus s, anything. Okay. So since if it is 0, real part of 0, then it is not defined. Correct. So in that case, such case, if you apply here, so real part of s, what will be the answer? 0 or something?
It's greater than -3.
0 minus 3. Correct now. So if 0 minus 3, in that case only 0. Now here it is s plus 3 is there. That's why it is 0 minus 3. But we will not write 0 minus 3. We will write after final minus 3.
-3.
This is the way. Okay. So now I will give you some example later on. Just next property. Properties, third property. Okay. So third property is the derivative of of transform of properties. That means derivative properties. Okay. Now. So what is that called? That is derivative property Okay, when it is multiplied by some t or t power of t. So what is that one? Derivative property or derivative of transform. Okay, transform property. Okay, now let us see what is that one. Okay, first I will write the statement. Okay, statement only. Statement. So what is that? Now, if f of t, okay, is a function, okay, whose Laplace transform is capital F of s. So in that way I am writing. Okay, if f of t is a function having Laplace transform capital F of s. Okay, so this is the form. That is, sometimes you can write like that also. Laplace transform of f of t equals to L of s. Sorry, F of s, capital F of s. Correct. Then, okay, this is given. This part is sorry. This part, Control Z. This part is given. Now, what is the conclusion? Then the function. Okay, t to the power t into f of t. What will be the Laplace transform? Correct. Then t square f of t. What will be the Laplace transform? So you just see, second part is given. First part is not given. Correct. tq f of t. So and so on. So we can write the function t to the power n f of t. What will be the Laplace transform? Correct. When t n equals to, what is the value? N equals to 1, not 0, 2 and 3 and so on. Correct. And that is also integer. Okay. Function also have Laplace transform. Okay, what is that one? I will write now. Laplace transform of t to the power n f of t. You are writing, okay now? If you are not writing, okay, I will go to the next page. It will be not available. That time you will not able to answer. Nth derivative of the function f of s with respect to s, dsn. Okay, this is the answer. And of course, the provided, you can find that one, provided the real part of s is greater than something based on that function. Okay, so I am not writing here. So not 0. Okay, based on the function. So you understood then? So if you know the Laplace transform of f of t, then it is very simple to find the Laplace transform of t multiplications with integer coefficient, integer indices. Indices only, na? So that's all. So now I will go to the blank page, new page. Okay. So what is the next step? Some application, correct? So just few minutes back, okay, na? I will tell you what actually Laplace transform of. I should not say. Okay, I did mistake. I have already informed you. Okay. What is the answer? I think odd roll number did yesterday. Sorry, in the last class, that one, na? Sin 3t or sin 80. So which one we have to apply?
Second one is a derivative thing.
Why?
Because it is t multiple of a function.
Okay. If it is multiplied with e to the power 80, e to the power t,
then we'll do that first method, sir.
Good. Very good. So it is the applications of derivative of a transform function. Okay, now. So is it okay now? T into sin 3t, actually I have changed to t square into sin 3t. Okay. So this one we have to apply. So applying, what we have to apply? Now we have to apply the properties of Okay, derivative of transform properties, that one, Laplace transforms. So what will be the answer? We know that. Okay, we know that. What we know? I don't know it. Sine 3t. You might be knowing. I don't know. We know. I have written. That's why we know. What is the answer? Wait, no response. Immediately you should response. You have done already this one.
3 by 9 plus s square.
What is your roll number?
27, sir.
Okay, good. Tell me. 3 by
9 plus s square.
s square plus 3 square. Am I correct? Is it okay? What I have written?
Yes, sir. Yes, sir.
Okay. So now Laplace transform of t square sine 3t. If you don't know these properties, the earlier property, what we have to do? 0 to infinity t square, sorry, e to the power minus st t square sine 3t dt. Can you find this one? How much time it will take? How many steps you have to do? Which one is easy? This one or earlier? We can apply this, the earlier solution as an earlier concept. I think integration is easy, correct? E to the power minus st t square sine 3t dt. This integration, what will be the answer? 0 to infinity e to the power minus st t square sine 3 thrice t dt. Find it, you will get the answer. Answer. Correct. If you don't want to do this one, then Laplace transform t square sine 3t equals to, okay, equals to, okay, applying, you have to write. I'm not writing now. Applying that. Okay. So what is the answer? No, minus 1 power. What?
Whole square.
Whole square. D by ds. Is it correct?
No, sir. D square by ds power 2.
Okay. dt2 ds2. Correct. On capital F of s. What is this one? Am I correct now? So now you find minus 1 whole square means positive 1 only. Sorry. Minus 1 into minus 1, so 1. Okay, so what we have to do then next? Okay, so now we have to find the derivative, second time derivative, two derivatives. Okay, double derivative d2, okay, ds2 on, okay, of is 3 by square plus 9. I need answer. I should not do this one, this derivative, 2 times derivative. But even I don't know what is the time. Okay, this full screen actually there is no display. Okay, so you should stop me at appropriate time. Okay, what is that one? d2 2 by ds2 of 3 by s square plus 9. Simplest form. Okay, tell me the simplest form, then only I will write. So this one, now simple calculation. Okay, first derivative you do it and you will get one function. Don't simplify that one, keep as it is. Then again you do the double derivative, sorry, another derivative. If you simplify it, it will be tough for you. Okay, so you need some time, I know. We will complete first, I will check. Oh, sorry. come after 10 minutes. I'm in class. No. So slow.
Sir, we got minus 6 into s square plus 9
What-
minus
what is
24 s square by s square plus
What is your roll number?
44, sir.
44. Tell me the answer.
Minus 6 into s square plus 9
Minus.
minus 24 s square by s square plus 9 whole cube.
If you tell like that, right? Minus 6 into.
S square plus 9
Hmm.
minus
Minus.
24 s square
Hmm.
by s square plus 9 whole cube.
Okay. This one. Okay. You can little bit simplify minus 65 s square plus 9. After second derivative, you simplify it, not before. So that. Okay. Otherwise, it will be very straightforward. So 24 square by. Okay. S square plus 9. Why you have to do this one? No. This is actually what you did Laplace transform. But in your case of applications, again you have to find the inverse Laplace transform. So that time actually such type of functions you can't find. So this type of function only you can find the answers. So better to write like that. Okay. Your answer is there, but process better to write after finding the derivative. Is it correct? Anything different answer? Maybe calculation is
something else.
tell me what is your roll number?
My name is 62, sir.
Okay. 62. Correct.
Yes, sir.
Okay. What is the answer? No problem. All
Minus 6.
minus is there. Okay, minus 6 square plus 9 minus 24. Oh, minus 24. Okay.
Sir,
Yeah. Your roll number.
my roll number is 43.
Okay. Right.
Sir, my roll number my answer is minus 6 bracket minus 3 s square plus 9 by
By
s square plus 9 the whole cube.
okay. So what I will do now, I will tell you. Okay. You are getting 3 answers now. Okay. You are getting my answer. 3 answers you are getting. So better to go slow and perfectly you should do that always. Okay. Na?
Sir, I got a different answer. I got same Sanjay's answer plus 24 I got.
Okay. Okay. Wait, one minute. How many students are there in your EC department?
59.
Now, so I will get 59 answer. I think so. If I wait for some time.
The same answer that the first answer, but plus 24.
I am not telling you only.
Sir,
Okay.
yes, sir, it's plus 24, sir. I forget minus sign into the.
Sir, I also got I have simplified it, but I have done in simplified form. But the extended form minus 6 bracket s square plus 9 the whole square plus 24 s square bracket s square plus 9 by s square plus 9 the whole power 4.
Yeah, that's what I got.
Okay. I understood. So that's what I'm telling. I don't know the name. Okay, all of you. Okay, since you are not here, so online only. So it is really tough. So whatever may be, my suggestion is don't go first. Go slowly but carefully. Okay, na? If you are first only, then you have to go. Means you have to check every step is correct or not. Clear? So if your answer this transformation itself wrong, then if you take, say for applications, when you are applying all this one for any particular problem, if you take the inverse again, that one, surely it will be different. So that means your final answer will be different. Correct? So this is the intermediate step only. Now we are learning only the Laplace transformation. We are not applying on any system. Okay. And then after next class we will discuss regarding the inverse transform. Correct. And then if you take the inverse transform of wrong Laplace transform, okay, now then it will be surely your answer will be different. Okay. So that's why I'm telling you, carefully you do it. Don't go fast. Okay. If you really fast, then also you check it, your answer is correct or not. Okay, now each step. Okay. So whatever may be the final answer, I don't know. Frankly speaking, I don't know the answer. What is that answer? You check yourself, and if you are matching with 2-3 fellow, that means you are correct only. Okay. So next. Okay. So next you write down. So since so many confusion are there, okay, I will give you some problems. You just find the Laplace transform of such problems for your home practice only. Don't send to me. Okay. I repeat, don't send to me. If I need, I will inform you that you send to me. Okay. So these are the main properties we have already studied. Rest are only so very simple one, multiply, etc., etc. So no need all these things. Okay. Now I will give you some problem. Okay. So for odd roll number and not for now. Okay, now for odd roll number and even roll number. What everybody should write. Sorry, you all the problems you should write. Okay, now for your practice later on. Okay. So now first question for odd. Okay. So this one is okay. 3 cos of twice t minus t cube. Okay, for even. Okay, 2 cos of 3t. Okay, plus 5 sine of 3t. Sorry. So sine of raised t. So this one is very simple. Second one will be little bit tough. Okay, so 2 e to the power minus 3t. Okay, sine 2t for this case. Okay, 6 t cube. Okay, minus 3 t square. Okay, t square into sine of 5t. Okay, next one, third one only, final one for all of you. Okay, t square e to the power minus 3t. So what we are going to find? We are going to find only Laplace transform. Okay, okay, plus t cos of 2t. Here it is e to the power minus t cos of 2t. Okay, plus or minus. Okay, minus 4t. Okay, e to the power minus 3t. Yeah, this one. Okay, find the Laplace transform. Okay, don't do all this integration. Wherever you can apply any of these properties. Okay, today's 2 properties, important property we have studied. Okay, so try to apply that one. Okay, where you can't apply that too, you can find the integration. I repeat. Okay, don't find the integration for all the Laplace transforms. You have to use the technique how to find easily, okay, the Laplace transform of the complicated functions. Okay, so find the Laplace transform of the above functions. So only 3. Okay, so don't send me. Okay, listen to me. Okay, only for practice, but you should do that one. Okay, so next class we are going to discuss something else. We need all these transformations. Okay, so that you can easily handle the next class. That's all. If you have any query, you can ask me now. Can I minimize this screen, full screen? You have? All of you have written all this problem, I think so. You write all the problems, even your roll number may be odd or even. Okay. But you just practice for odd if your roll number is odd. In future, for future, okay, you can keep it with you. Okay. So that's all. Okay, now, do you have any doubt?
Sir,
Hmm.
sir, Laplace of t power n has some concept of gamma function as well, na?
Yeah, it is there. But are you ready to integrate the gamma function? So that integration is not now. Gamma function is also there. So if it is integration gives like say gamma function, easily you can apply. You can use that one gamma function. You have already studied gamma beta function.
Yes, sir.
Have you
Mr.
studied?
Yes.
Which semester?
First,
Previous semester, sir.
Last semester.
Okay,
Yes,
okay,
sir.
okay. That means that concept you have. That's why actually
that
I
gamma
got that.
to infinity
Yes.
per minus x as per
Yeah,
minus
yeah.
1 dx.
Yeah, but you can find that one. Okay, if it is follow, if you have during say sometimes you can't apply the what is that called some properties. Okay, now you can't apply the property. Okay, that time if your integration is like that form, you can apply the gamma beta function to find the integration. Any process you can find the integration. Okay, that means UV integration formula is there and so many are there. Okay.
Yes, sir. Thank you.
Okay. That's all. Okay, you can leave the meeting now. We'll meet
Thank you, sir.
in the next class again. Okay.
Thank you,
Thank
sir.
you, sir.
Thank you, madam.
Thank you, sir.
Immediately you should. Okay, okay. I should leave the class. Okay.